Hello, and today we are going to learn the types of function. This topic is in class 11 and class 12 also. We have this topic like types of function. So there are four types of function. First of all, so one-to-one function, and it is also known as injective function. One-to-one function is also known as injective function. Then many-to-one function. Okay, second one is many-to-one function, and the third one is on-to function, and it is also known as surjective function. So on-to function is nothing but the surjective function, and the last one is one-to-one and on-to function. One-to-one and on-to function. So one-to-one and on-to function is known as bijective function also. Okay, so first one is one-to-one function, that is injective function. Second one is many-to-one function, and the third one is on-to function, that is the surjective function, and the last but not the least is bijective function, that is both one-to-one and on-to function. So let us see first the one-to-one function, that is injective function also. Here you see the F1 is indicating the function between set A to B. Okay, the member of set A is 1, 2, 3, and the member of B, set B, is A, B, C, D. So this function A to B is the one-to-one or injective function. Why? Because if you check the image of 1, that is f of 1, that is equal to C only, and image of 2 is equal to B, and image of 3 is equal to A. So all element or member of set A has the distinct or unique image, you can say distinct image in set B. So image of 1 is C, image of 2 is B, and image of 3 is C. So all, I repeat, every element of A has distinct or unique image in B, and this is the definition of injective function. So a function f A to B is known as injective function if every element of A has distinct or unique image in B. Okay, so let us go to the second diagram. Here also F2 is indicating the function between A to B. So again 1, 2, 3 is the member of set A, and A, B, C, D is the member of set B, and so image of 1 is A, image of 2 is C, image of 3 is B only. So this is also injective function because every element of A has distinct or unique image in B, distinct image in B and unique image. Let us go to the third one, the third function F3 between A to B. Here again the 1, 2, 3 is the member of set A, and A, B, C is the member of set B. So here image of 1 is A, image of 2 is B, and image of 3 is C. So let us check the last function, that is function 4. Here again image of A is in B only. So the member of A are 1, 2, 3, and the member of B are A, B, and C. So you can say image of 1 is B, image of 2 is C, and image of 3 is A. So all member of A has unique and distinct image in B. So at last I am repeating the definition of this injective function. So if the every element of A has distinct or unique image, distinct or unique image in B, then that function A to B is known as one-to-one or injective function. One-to-one or injective function. Okay. Second one is many to one function. Second one is many to one function. In this function, so any if you have the many to one function like f a to b, so two or more than two element of a have the same image in b, in set b. So let us see the function first, f1. So there is a function between set a to b. So 1 2 3 4 are the element of set a, and a b c d are the element of b. Here you see the 1 and 2 that are the element of set a having the same image like c. So c is the image for 1 and 2. 1 and 2 having the same image like c. So two element 1 and 2 of set a have the similar image, same image as c, and image of 3 is d and image of 4 is a. But these two elements 1 and 2 of set a has the same image as c. So here image are not distinct. Okay, now you check the function number 2. So it is the function between set a to b. So the member of a is 1 2 3 4, member of b is a b c d. Here also the image of 1 and 2 is same as b. So if you find the image of a1, that is f of 1 is equal to b and f of 2 is equal to b. Again here f of 3 is equal to d and f of 4 is equal to d only. All the element of a, all the members of a, that is 1 2 3 4 have the image in set b, but 1 and 2 has the same image and 3 and 4 has the same image. So it is many to one. So many, you can say like that, you can remember like that also. So many element, more than one element of a have the same image, in set b. Okay, let us go to the third one, the function f3 between a to b. Here member of a is 1 2 3 4 and member of b is a b c. Here a, image of 1 is a, image of 2 is b, but image of 3 and 4 are c only. So more than one element, more than one member of a has the same image, that is c, in set b. So two members of set a has the same image in set b. Okay, you see the last one, that the function f4 between a to b. Here the 1 2 3 4 is the member of a and b are the member of b. So the image of a is, image of 1 is a and image of 2 is b and image of 3 is again a. You see here, so image of 3 is again a, then image of 4 and 1 is b. So again more than one member of a having the same image in set b. So this type of function is known as many to one. Okay, so let us define. So in a function f to a, in a function f, a to b is said to be a many to one function if and only if two or more than two element of a has the same image in b. So here two or more than two element of a have the same image in set b. So this is known as many to one function. Now the third one is onto function, that is surjective also onto function. So let us see the function f1 is a surjective function between a to b. So member of a is 1 2 3 4, member of b is a b c d. So the element of a, that is 1, has the image 1, the image of 1 is a and image of 2 is b and image of 3 is c, image of 4 is d. So here also all the member of b is the image of member A. Okay, so no element here, no element of set B is left here. So this type of function is known as surjective or onto function. Onto function means all the member of set B have all the member or all the element of set B is the image of some member of set A. Same thing here, you see for function 2. So 1, 2, 3, 4, 5 is the member of set A, and here A, B, C, D is the member of set B. So here again, so you can say a function f A to B is said to be surjective if and only if all the element of B are the image of some element of A. Here the element of B is A, B, C, D, and element of A is 1, 2, 3, 4. So 1 has the image as A, B has image B, 3 and 4. For the 3, D is there, and 4 and 5 has image as C. So here all the member of B is covered. No member is remaining here. All A, B, C, D are the image of some element of set A. Same thing here in function 3 also. So 1, 2, 3, 4. 1, 2, 3, 4 is the member of set A, and A, B, C, D again is the member of set B. So 1 and 2 have the image like A, and 3 image of 3 is B, image of 4 is C, image of 5 is D. Again all the member of B, that is A, B, C, D has been covered. So all the member of all the element of all the member and element anything of B are the image of some element or some member of set A. Same thing here, you see for function 4. So 1 has image like A, B is the image of 2, C is the image of 4, and D is the image of 3. So no element is remaining in set B. So all the element of set B is the image of some element of A. So this type of function is known as onto or surjective function. I repeat, this type of function is known as onto function or surjective function. So now let us define the surjective function. A function f A to B is said to be surjective function if and only if all the element of B are the image of some element of A. Okay, so no element of B should be remaining here. So I repeat, a function f A to B is said to be surjective if all the element of B or are the image of some element of A. Okay, so let us move to, so fourth one here is one to one or and onto function, both. It is bijective function, it is known as bijective function. You know, one to one function is injective and onto function are surjective. So this type of function is also injective and surjective. That's why it is bijective function. It is one to one also and onto function also. So it is known as bijective function. One to one injective, onto surjective, injective and surjective is bijective function. Okay, so let us see one example of function f1 between A to B. Here all the element of B is also covered, and so the image of 1 is C, image of 2 is D, image of 3 is A, image of 4 is B only. So all the element of B has been covered, and the element of B are the distinct image, are the image only, distinct image of distinct member of A. So it is surjective also, by injective also and surjective also. Why it is injective? Because each member of A is having distinct image in B, unique image in B. So image of 1 is C only, image of B, image of 2 is D only, image of 3 is A only, and image of 4 is B only. So all the element of set A have unique and distinct image in set B. So it is injective since all the members of set B are the image of some element of set A. So none of the member are remaining. So all the member here are covered in set B are the image of some element of set A. So function f1 is the bijective because it is injective also and it is surjective also. Same thing here in function 2. You can say by looking at the figure, you can say function 2 is injective because all the member of set A have unique and distinct image in set B. Now you see in set B all the member of set B has been covered, means no member is remaining here. All the members are the image of some element of set A. So this is, you can say this is surjective also. No element is remaining here in set B. Same thing in function 3. Function 3 is bijective because all the member of set A has the unique and distinct image in set B. So it is injective, and it is surjective. Why? Because no member of set B is remaining here. All the member of set B are the image of some different element of B, element of set A. So it is injective also and surjective also. So this function f3 is surjective. Okay, so what about this function 4? It is also, you can say it is on 1 function because it is injective. One element of A have the only one image in B, so it is 1 to 1, it is injective. Now you see in set B all the element has been covered, so all element of B are the image of some element of A. So it is bijective, sorry, it is surjective also. So by this way we can say the function f4 is injective also and surjective also. So function f4 is bijective only. So let us define this. If a function f A to B is 1 to 1 and on to both, then it is known to be as bijective. It means the function is both injective and surjective. Okay, thank you very much. I hope this will help you. So if you are very new to my channel, so please subscribe and share to your friend also, and at least give one like to this video. So once again, thank you for watching. So keep watching. Thank you very much.